Download this code from codegive.com, link in the description below. OK, let's dive deep into the world of handling large file uploads. This is a common challenge in web development, and a poorly implemented system can lead to slow performance, failed uploads, server crashes, and a frustrating user experience. This guide will provide a detailed explanation with best practices and code examples using different approaches. The problem: why are large file uploads difficult? 1. Memory consumption *. The naive approach of reading the entire file into memory on the server before processing it is a recipe for disaster. Large files can quickly exhaust server memory, leading to application crashes and potentially affecting other processes. 2. Timeout issues *. Large uploads take time. Web servers and load balancers often have default timeout settings. If the upload takes longer than the timeout, the connection will be closed prematurely, resulting in a failed upload. 3. Network instability *. Network connections can be unreliable. A brief interruption during a large upload can corrupt the file or cause the upload to fail, forcing the user to restart the entire process. 4. Security risks *. Unrestricted file uploads can open doors to security vulnerabilities. Attackers can upload malicious files, example viruses, scripts, that could compromise the server. It's crucial to implement proper validation and security measures. 5. Performance bottleneck *. Large uploads can consume significant server resources, CPU, bandwidth, disk I/O, potentially impacting the performance of other services running on the same server. 2. Key techniques for handling large file uploads. The core strategies to address these issues are: 1. Chunking / resumable uploads *. Divide the file into smaller pieces, chunks, and upload them sequentially. This allows for more efficient memory management, easier recovery from network interruptions, resumability, and progress monitoring. 2. Streaming *. Process the file data as it arrives, without loading the entire file into memory at once. This is crucial for memory efficiency. 3. Asynchronous processing *. Offload the file processing to a background task, example using a queue, so the web server can immediately return a response to the client, improving responsiveness. 4. Direct-to-cloud uploads *. Azure Blob Storage, etc. Bypass your server entirely and let the client upload the file directly to a cloud storage service. This reduces the load on your server and leverages the scalability and reliability of cloud infrastructure. 5. Client-side validation *. Perform basic file validation on the client side, example file size, file type, to prevent invalid uploads from reaching the server. 6. Server-side validation *. Always validate the file on the server side, even if you've done client-side validation. This is crucial for security. 7. Rate limiting *. Limit the upload speed to prevent a single user from consuming excessive bandwidth. 8. Error handling and retries *. Implement robust error handling and retry mechanisms to gracefully handle network interruptions and other errors. 3. Approaches and code examples. Here's a breakdown of different approaches with code examples using Python and Flask, a popular web framework. Adapt the code to your preferred language/framework. A basic upload, not recommended for large files. This is the simplest approach, but it's only suitable for small files. Upload.html, basic template. Why this is bad for large files ***. The file.save method reads the entire file into memory before writing it to disk. No progress updates are provided to the user. No resumability in case of network errors. Very vulnerable to timeouts. B chunked upload with Flask, more robust. This approach breaks the file into smaller chunks and uploads them sequentially. Asterisk client-side, JavaScript example using Fetch API. Explanation of the chunked upload approach asterisk. 1. Client-side chunking asterisk. The JavaScript code divides the file into smaller chunks using file.slice. The chunk size, example 1 MB, is a configurable parameter. 2. Sequential uploads asterisk. The client uploads each chunk to the /upload endpoint using fetch. 3. Server-side handling asterisk. Asterisk. The server receives the chunk and saves it to a temporary file. The file name includes a unique upload ID, generated if it's the first chunk, and the chunk number. Asterisk. The server checks if all chunks have been received. Asterisk. If all chunks are received, the server concatenates the chunks in the correct order to reconstruct the original file. Asterisk. Finally, the temporary chunk files are deleted. 4. Resumability asterisk. The upload ID allows the upload to be resumed if it's interrupted. If the upload is interrupted, the client can resend the remaining chunks, including the same upload ID. The server can then use the upload ID to locate the previously uploaded chunks and resume the process. 5. Progress tracking asterisk. The client updates the progress bar based on the number of chunks uploaded. Improvements for the chunked upload approach asterisk. Asterisk. Error handling asterisk. Implement more robust error handling on both the client and server to gracefully handle network interruptions and other errors. Asterisk. Concurrency asterisk. Consider using multiple parallel fetch requests to upload chunks concurrently, potentially speeding up the upload process. However, be mindful of server resource limitations. You might need to implement a queue to control concurrency. Asterisk. Checksum verification asterisk. Calculate checksums, example MD5, SHA-256, for each chunk and the entire file on both the client and server to ensure data integrity. Verify that the checksums match after the file has been reconstructed. Asterisk. Cleanup asterisk. Implement a background task to clean up incomplete or abandoned uploads based on the upload ID. This prevents temporary files from accumulating indefinitely. See Direct to Cloud Upload, recommended for scalability. This is the most scalable and efficient approach, especially for large files. The client uploads the file directly to a cloud storage service like Amazon S3, Azure Blob Storage, or Google Cloud Storage. Your server only provides temporary credentials and handles the post-upload notification. Example using AWS S3 asterisk. 1. Server-side, Flask generate pre-signed URL. Asterisk. Important asterisk. Replace S3 underscore bucket underscore name, AWS underscore region, AWS underscore access underscore key underscore ID, and AWS underscore secret underscore access underscore key with your actual AWS credentials and bucket name. Never hard-code these credentials directly into your code. Use environment variables or a secure configuration management system. Asterisk. The ACL parameter in the pre-signed URL controls the access permissions for the uploaded file. Choose an appropriate ACL setting based on your requirements. Public read makes the file publicly accessible. 2. Client-side, JavaScript upload to S3. Explanation of the direct-to-cloud approach asterisk. 1. Pre-signed URL asterisk. Your server generates a pre-signed URL using the AWS SDK. A pre-signed URL is a temporary URL that grants permission to upload a specific file to a specific S3 bucket. The URL is valid for a limited time, example 1 hour. 2. Client-side upload asterisk. The client uses the pre-signed URL to upload the file directly to S3 using a PUT request. Crucially, you must set the content type header in the PUT request to the correct MIME type of the file. 3. S3 configuration asterisk. Asterisk cores, Cross-origin resource sharing. You need to configure CORS on your S3 bucket to allow uploads from your web application's domain. This prevents browser security errors. In the S3 console, go to your bucket, then Permissions, then CORS configuration and add something like this. Replace the asterisk with your website's origin, example https://www.example.com. Be cautious about using asterisk in production, as it allows requests from any origin. IAM, Identity and Access Management. Your server's IAM role needs permission to generate pre-signed URLs for the S3 bucket. The IAM role should have the S3 put object permission for the bucket. For post-upload notification, optional, you can configure S3 to send a notification to your server, example via SNS, SQS, Lambda, when a file has been uploaded successfully. This allows your server to update its database, trigger other processing tasks, or send a confirmation email to the user. Benefits of direct-to-cloud uploads ** scalability * offloads the upload process to a highly scalable cloud storage service. * performance * reduces the load on your web server, improving performance. * reliability * leverages the reliability and durability of cloud storage. * security * uses temporary credentials, pre-signed URLs, reducing the risk of exposing your AWS access keys. * cost-effective * pay only for the storage and bandwidth you use. Streaming uploads ***. If you need to process the file data immediately as it arrives, without saving it to disk, you can use streaming uploads. This is useful for tasks like video transcoding or image processing. Client-side example. Explanation **. One client-side streaming **. The client sends the entire file as the request body in the post request using the Fetch API. The content type header is set to the correct MIME type of the file. 2. Server-side streaming **. The server accesses the file data as a stream using request.stream. The server reads the stream in chunks using request.stream.read, 4096. The server processes each chunk as it arrives. In this example, we're simply printing the length of the chunk, but you could perform any desired processing. The server can also send data back to the client as a stream using a response object with a generator function. Important considerations ***. Content type * always set the content type header in the request to the correct MIME type of the file. This is essential for proper server-side processing. Error handling * implement comprehensive error handling to gracefully handle network interruptions, invalid file types, and other potential issues. Security * implement proper file validation and sanitization to prevent security vulnerabilities. Resource management * be mindful of server resource usage. Streaming uploads can still consume significant CPU and memory if the processing is intensive. Consider using asynchronous processing to offload the processing to a background task. 4. Security best practices. Security is paramount when handling file uploads. Here are some essential measures. 1. File type validation * strictly validate the file type on the server side. Do not rely on the client-provided file extension. Use libraries like PythonMagick or libmagick to determine the actual file type based on its content. This example checks the MIME type against a whitelist of allowed types. 2. File size limits * enforce strict file size limits to prevent denial of service attacks and resource exhaustion. 3. File name sanitization * sanitize file names to prevent directory traversal attacks and other vulnerabilities. Remove or replace any characters that could be interpreted as special characters by the operating system, example /, and. For content sanitization * scan uploaded files for viruses, malware, and other malicious content. Use antivirus software or specialized libraries for content scanning. 5. Secure storage * store uploaded files in a secure location with appropriate access controls. Avoid storing files directly within your web application's public directory. Use a dedicated storage service like S3 or Azure Blob Storage. 6. Authentication and authorization * require users to authenticate before uploading files. Implement proper authorization to ensure that users can only upload files to authorized locations. 7. Regular security audits * conduct regular security audits of your file upload system to identify and address potential vulnerabilities. V. Choosing the right approach. The best approach for handling large file uploads depends on your specific requirements and constraints. Small files * the basic upload approach, might be sufficient, but it's generally not recommended. Medium-sized files, up to a few hundred MB chunked uploads, provide better performance and resumability. Large files, hundreds of MB or GB direct-to-cloud uploads, are the most scalable and efficient solution. Real-time processing * streaming uploads, are necessary if you need to process the file data immediately as it arrives. High availability and scalability * always opt for direct-to-cloud uploads and asynchronous processing to ensure that your file upload system can handle a large volume of uploads without impacting the performance of your web application. This guide has covered the essential concepts, techniques, and best practices for handling large file uploads. Remember to carefully consider your specific requirements and choose the approach that best meets your needs. Always prioritize security to protect your server and your users. Good luck.